Hello folks, and welcome to Unit 6, Rational Exponents and Radical Functions. So today we are going to spend a little time to see how rational exponents are related to radicals. You'll need your notes, a pen or a pencil, and a calculator. And we'll get started. So today we're going to learn some new notation. So the new notation we are going to learn is radical versus rational exponents. So now you need to know what a radical is and you need to know what a rational exponent is. Well, you see that 12 there. If I take that 12 and I insert that little x and then that sign, that is called the radical sign. Okay, that's a symbol for radical or a root. Okay, the 12 is the radicand. So that could be a variable, or it could be a number and a variable, but whatever is underneath the radical sign, that is your radicand. The x is the index, and the index could be any number, like a 2 or a 3 or a 4 or 5, okay? We don't usually put the 2 there when we're talking about square roots, so make sure that you know that if you don't see a number there, that means you're talking about a square root. And then any other number that you put in there will tell you what kind of root it is. So if there's a 3 there, that'd be a cube root. Okay, so the index is like the root. What root are we talking about? So that's what a radical is. Now let's talk about a rational exponent. What does that look like? Well, this says 9 to the power of 1/2. Okay, that isn't 9 and 1/2 like a mixed number. Okay, that is 1/2 is raised up, so that's 9 to the power of 1/2, and that 1/2 is called a rational exponent. Now the reason why it's called a rational exponent is because remember rational means ratio, and ratio means fraction. Okay, so this is the fraction form, and so a rational exponent is an exponent that has a fraction in the exponent, not just necessarily a 2 or a 3 or a 5 that we've been working with. Okay, so what we're going to do is we're going to make a connection between radicals and rational exponents. So that's what our job is today, is to figure out what the connection is between these two things. All right, so while we do that, let's start by talking about how roots are related to that fraction or rational power. So if I were to put this in my calculator and type in 25 caret, that's what I use when I type it into my calculator, and then parentheses 1 divided by 2. Some of you have to use what's called the x to the y key, and some of you it's y to the x. So depending on which kind of calculator you have, typing this in will vary. All right, so but my calculator, I'm going to type in 25 caret parentheses 1 divided by 2, and I get a 5. When I take 36 to the 1/2 power, I get 6. When I take 49 to the 1/2 power, I get 7. And when I take 64 to the 1/2 power, I get 8. And so when I'm looking at the answers to these problems and what I started with, we should see a connection between those numbers. And those connections is that 5 is a perfect square, or 25 is a perfect square, and 5 times 5 is 25. So what that means is when I take 25 to the power of 1/2, I am actually taking the square root of 25, or the square root of 36. So the 1/2 power represents a square root. Okay? If I want to talk about the 1/3 power, and I put that in my calculator, 8 to the 1/3 power, I would get 2. If I took 64 to the 1/3 power, I'd get 4. Well, the 1/3 power represents a cube root. So 8 to the power of 1/3 is the same thing as the cube root of 8. So these are cube roots. Okay? So how are rational exponents related to radicals? I'll take a minute to write down this little table. You need the rational exponent, what it means, okay, and then the radical that goes along with it. So if I were talking about x to the 1/2, here's my rational exponent is 1/2. That means I have a square root, and I would write that, I would write that as the square root of x. Now remember, back in the second slide, I was talking to you about that index. Now if it's a square root, that 2 doesn't have to be there, okay? But if you want to, you can. Just know that if there isn't a 2 there, we are talking about a square root. X to the 1/3 power is called a cube root. And when I write the cube root, I would write the radical. My x is my radicand, or my base, okay? And the 3, sorry, my board is being temperamental today. My index would be the 3. So this would be called a cube root. If I had x to the 1/4, that would be a 4th root. And how I would write that is I would write x as the radicand, because that's my base, and the 4 would be the index that I would put there. Okay, so this is how rational exponents relate to radicals. But what if I had 8 to the 2/3 power? Then what? Okay, well, if I'm looking at that, remember, that says 8 to the 2/3. That doesn't mean 8 and 2/3 as a mixed number. Okay, that's 8 raised to the power of 2/3. So be careful with that, because a lot of times we write it like this, but we mean the power, and I'm kind of particular about that. So make sure that your power is raised up, okay? Now, what we're going to do is we're going to talk about what that means, okay? So we're going to go ahead and talk about how do we change forms from radical to rational. So what does it mean to be a radical? Remember, what it means to be a radical is that it has, or radical form means that it has a radical sign, or one of those roots. A rational exponent means that it has an exponent that can be written in fraction form. So what this is telling me is, how do I get from rational exponent form to radical, or vice versa? So if I were going to start with a to the power of mn, okay, and I wanted to get to the radical, I would have to know what I am working with. So the n, when we talk about the n, so we can go back and forth between the two, the n represents the index. So that's the denominator. The denominator of the rational exponent is the index. That is also known as what type of root I'm working with. Okay, the m represents what power I am raising my root to. So am I raising my root to a 1? Am I raising it to a 5? So the m represents what I'm raising my root to. Okay, so I want to be able to use this to go back and forth between radical and rational exponents. So let's do a couple of examples of each type. So first I'm going to start out with some rational exponents, and I want to put them in radical notation, which means I need to use the radical symbol when I'm rewriting these into radical notation. So go ahead and write these down. As we write them down, we will do them. So this says 7 to the 1/2 power. Well, just remember, we were working on this a couple slides back, and the half power meant the square root. So the square root of 7. It's my base. In my exponent, my base becomes my radicand. Now I could write a 2 here, but I don't have to with square roots. Okay, this says 4 to the 4/3 power. Remember, the index or the number in the bottom represents the index or the root. So this would be 4, and that would be underneath a cube root, the third root of 4. And this tells me how many times I'm going to raise my power. Okay, so I'm raising it to the power of 4. Okay, so this would be the cube root of 4 to the 4th power. If I were going to rewrite 2 to the 5/3 power, I would look at the bottom. That tells me the root. So this is the cube root of 2. The base becomes the radicand. And how many times what am I raising my root to? I'm raising it to a 5. Okay, so this says 7 to the 4/3. This would be the cube root of 7 to the power of 4. Index or root and what you're raising it to. This says 6 to the 3/2 power, so this would be the square root of 6, and all of that would be raised to the 3rd power. Now remember, I don't need to write that 2 there, but it's okay if you do. This says 2 to the 1/6 power. That would be the 6th root. Oops, excuse me, sorry. This would be the 6th root of 2. And it would be raised to the 1st power, but I don't really need to do that. So that would be the same as saying the 6th root of 2. Okay? Now let's go ahead and write the expression using rational exponent notation, meaning I'm going to take my radical and I'm going to write them in exponent form that have fractions. Okay? So how do we do that? If I look at this problem, this says the square root of 10. Remember, I know that's the square root because there's a little 2 there we don't see, but we know is there. And where does that go? When I'm going to write a fraction, remember the 10 becomes the base. I'm going to have a power with a fraction. The index goes on the bottom, and the top is what we raised it to. So this would be 10 to the power of 3/2. All right, the next one is the 6th root of 2. I would take and make 2 my base, and 6 is my index, so that goes on the bottom of my fraction. And this is all raised to the 1st power, and so it would be 2 to the 1/6 power. 4th root of 2 to the 5th power would become 2 to the 5/4 power. Make sure you're writing these down. The cube root of 2 would be the same thing as 2, and this is raised to the 1st power, okay, to the 1/3. The 6th root of 10 would be 10 to the 1/6 power. And number 6 would be the cube root of 10 to the 7th power would be 10 to the 7/3 power. And so that's taking radical to rational. And you need to be able to go back and forth, radical to rational, rational to radical. All right, now we need to be able to evaluate using our calculator. Now some of you have a TI calculator and some of you have backwards kind of calculators. So make sure that when you are using your calculator, you know how to use it. So if I were going to put this in my calculator and I were using the TI-80 or any kind of TIs, this 30x one, I would type in the number 3, and then it's not the square root button, but it's pretty close to the square root. Here's the squared, here's the square root button. It's the one above this caret sign right here. So I would hit second caret, and that's going to give you this symbol right here, x root. So what this tells the calculator to do is to put the 3 in for the index. And then you would type in -8 in parentheses. Now, because this is a cube root, you can take the cube root of a negative number. You can't take the square root of a negative number, but you can a cube root. And when you put that in your calculator, you should get -2. Now, sometimes calculators, you have to do it backwards. So you type in 8, negative, that, and then a 3. But it just depends, you know? It depends on what kind of calculator you have. So it's really important that you figure out how to use your calculator and make sure that you, when you type this in, you get a -2. Now, what if I wanted the fourth root of 65? Same thing. I type in a 4, I type in that X root button, and then I type in 625, and you should get 5. Okay, so make sure you're checking your work and getting that value. If you have any questions, please make sure that you understand how to use your calculator. That's really important. Okay, so that's radicals. How do I type in powers into my calculator? Now, I touched on that a little bit earlier again, but let's just review. So in my calculator, I would type in 256. I'd use the caret button, and then because I'm raising it to the power of a fraction, I need to make sure that I use 1 divided by 4 in parentheses, or 1, the ABC button, which is your fraction button, 4. Okay, and when you do that, you should get a 4. Make sure that when you type it in, you get a 4. If I take 32 to the 1/5 power, I should get a 2. So just make sure that you know how to use your calculator. Okay, that's really important. Okay, so that is all I have for you today, and we will see you tomorrow. Have a great day.